Hello all and welcome to this video where we look at the exponential function, as they call it in the textbook. It's just another exponential function where our base is e. Now what is e? E most simply is just a number. Just like pi is just a number, e is just a number. And in this case we can see e is equal to 2.718281. Now again, just like pi, it is irrational. Okay, so it has a non-repeating decimal pattern that goes on forever. It also comes from a sort of alternative definition. It's not that we just randomly picked 2.718 and said, oh, let's call it E. Like pi, how pi comes from the relationship between a diameter and circumference of a circle, or radius and circumference of a circle. E comes from this limit here. The previous video that I linked to in Google Classroom, the Eddie Wu video, goes into much greater depth about how E comes about. And if you haven't watched it, I highly recommend you watch it. It's a great explanation of where the number comes from. But just suffice to say, E is a number. It's just, let's just think of it as 2.718 or 2.71. And that means if we have it as a exponential function, where we put x to the n, we could just think of this as 2.718 to the x. So exactly like basic exponential functions, if it's not translated or dilated at all, it's going through 0, 1, because anything to the power of 0 is 1, even e. And then at x equals 1, the y value is e. At x equals -1, y is equal to 1 on e. So it follows the same pattern. It's just a number. It's just going to come up a lot. And it'll be pretty handy to use. So let's crack into using it. So our first problem is, let's just sketch it. And again, it helps to think of this. It's not to get scared seeing this e. It's just a number. That's all it is. So you could actually think of this as 2.718 to the power of x plus 2 minus 3. Okay, it's still an exponential function. But let's think about what are the transformations applied to it. H value you can see here, h is -2. Even though it's a plus 2 there, we got to think of switching the sign, and then we can also see our k value is minus 3. So we can think it's just like our standard graph, translated 2 units to the left and 3 units down. So I'm going to just sketch in the quick standard one. So we know before transformations, it's going to go through 0, 1, goes through 1e, which is 2.718, which is there, and it's going to go through, this would be our standard one. And this is -1, 1 on e. Okay. All we've got to do in this case is translate it. Okay? We have to translate it down. We have to translate it left 2 units, and we have to translate it down 3 units. So the easiest one of those points is 0, 1. That's much easier. So think of it, that's coming down 3 units. So it's going to come down 3 units to -2, and then it's also going to go across to -2. So this ends up over here. This point here, translated over here, and we are now at -2, -2. That's its translations. Same thing, this 1, e, we can just apply the same idea. Translate down 3, translate left 2. So it's going to come down to just under the axis, come across 2, it's going to be there, and then -1, 1 on e. Again, roughly we can think comes down 3 units, it's there, come across 2. Okay? So we have, and let me put those in green now, we have our 3 basic new points. So we can get rid of our standard graph. So we have those 3 basic ones, and we also know that the standard one has an asymptote coming across at y equals 0. That asymptote is now, again, also moved down 3 points. So we have an asymptote here at y equals -3. So we have that, we have 3 points. In this problem, I'm not worried about you getting the x-intercept yet, but we need to at least get the y-intercept. And as we have the hint here, okay, leave it in terms of e and have just a rough idea where it is. So if we're finding our y-intercept, because we are required to find in this problem, okay, to find our y-intercept, we let x equal 0 as usual. So we get y is equal to e to the 0 plus 2 minus 3. So we get e squared minus 3. Again, don't worry about thinking e. What is it? 2.718 all squared minus 3. Now we need to come up with a rough estimate of what this is. Now, 2.7 squared, well, we know that's between 2 squared and 3 squared, so it's got to be somewhere between 4 and 9. It's probably going to be skewed to the top end because we're getting closer to that 3. So we're going to think it's probably around 7-ish. Now, if you want to check, we can do a quick, let's just do 2.7 times by 2.7 and see what we get. 7 times 7 is 49, so put the 4, 2 7s are 14, plus 4 is 18. 0, 2 7s are 14 again, carry the 1, 2 2s are 4, plus the 1 is 5. Put that all over, so we get a 9, we get 8, 4 is 12, carry the 1. 1 plus 5 is 6, plus the 1 is 7. Now we were multiplying. Hopefully you think back to sort of year 8 multiplication algorithms or year 7. We had 2 decimal places being multiplied here, so we need to move our decimal place over 2 spots. So we get 7.29 as a rough estimate. So this is roughly equal to, should have put a roughly equal to, that's roughly equal to 7.29, take away 3, it's roughly equal to 4.29. So we can put in a final point there, which we wouldn't label as 4.29, we'll label as 0, e squared minus 3. What it actually is. So we have all our points. We can now connect them. Now again, I'm drawing on my tablet, so this isn't so great. So I've made 2 errors here where you'll get pinged for marks. I've clearly not crossed where I drew my intercept, so that would be half a mark. And I've actually crossed over my asymptote, so that would also half a mark. But for the sake of brevity, just know that you'd have to correct those mistakes. We don't need this as per the question. No x-intercept required at the moment. Gone the wrong way. Rightio. Of course, if we have a function, we need to think about the transformations, how to find them. So let's ignore, especially for this slide, let's ignore this. Okay. Let's jump straight into it. I'm going to show the dash method, and the start of inspection method is the same. Okay. We're starting with y equals e to the x, and we're going to y equals 4e to the power of x plus 2, then all take away 5. So we need to rewrite the second function where the operations are applied just to the x or directly to the y. So we have issues with the 4, that's not applied directly to the x, and the subtracting 5 is not applied directly to an x or y. So we want to rearrange this. So our first one stays the same. Our second one, we're going to get y dash plus 5. We add 5 to both sides, and then we divide by 4, and that's going to be equal to e x dash plus 2. So, dashes. Now we have it written in the form of operations applied to the x and the y, so we can clearly see that if we equate left and right hand sides, we've got y is equal to y dash plus 5 on 4, and we have x is equal to x dash plus 2. Now we want to rewrite these, and this is sort of what this is trying to say over here about transforming from the easy to hard. So we've started with an easy, we're transforming to a hard or more complex one. We need to rearrange these y dash and x dash equations. The better way to think of it is you always need to write these in terms of the dashes equal everything else, because we want to know what the new coordinate is. Our new coordinate, we want to know what our new y coordinate is and what our new x coordinate is. So we're going to just do a quick rearrangement. So we get 4y take away 5 is equal to y dash, and we get x take away 2 is equal to x dash. So this is literally saying my new coordinate, my new x dash coordinate is equal to the old one take away 2, which is what we, when we look at it through inspection, we can see, oh, my h value is -2, the sign switch. That's saying the exact same thing, and it's saying my new y dash coordinate is equal to the old one times by 4, then subtract 5. That's all that's saying. So we get to, if we want to write out what the mapping is, our old xy are going to get turned into x take away 2, and it's going to get turned into 4y take away 5. Here we're going for time, 10 minutes, okay? So reading off those, we just read these in regular operation order. If we're doing the dash method, we can see that we have translated 2 units in the negative x-axis direction, and we can also see, now we have to read in regular sort of bidmass order. We can see we have dilated by 4 units. Now it's the it's the y coordinate, the y value that's being affected. So what axis are we actually stretching away? Well, if we're increasing our y value by 4, we're actually stretching away from the x-axis, so we dilate by 4 units from the x-axis. And then lastly, we've got the subtract 5, so we have also translated 5 units negative y-axis direction. So there we go. Now this is, on the next slide, we're now going to look about, let's think about going back. And this is where this sort of, it's trying to have this rule. If we're going from an easy, or I guess we should say basic, to a complex equation, we want to rearrange these bits through here. But if we're going from a complex to a basic equation, you don't actually end up needing to have to rearrange, and I'll show you why that is in the case. Again, it's better to just think in terms of, we want to know what our new coordinates, our dashes, are equal to in terms of the old coordinates, so you just need to get the dashes by themselves. So, as same thing, this is going to rearrange exactly the same. We need to get in terms of operators applied directly to the y or the x. So this turns into y plus 5 divided by 4 is equal to e x plus 2, and we have still y dash is equal to e to the x dash. Now, equating the left-hand sides and right-hand side, we get y plus 5 on 4 is equal to y dash. That has to be equal to that. And we also get e to the x plus, oh, no, we don't need the whole e to the x plus 2. We just need the x plus 2 is equal to x dash. Okay. Now, as you can see here, we've already got written in terms of my new y coordinate is equal to the old one. Have all this done to it. Same over here. My new x coordinate is equal to the old one with all this stuff done to it. So we don't need to rearrange. We've already got it in terms of x dash and y dash, so this makes it a little bit easier. So we can see that the mapping is just those two equations. So we get x plus 2 and we get y plus 5 on 4. And read off your transformations. So we translated 2 units, and in this case, positive x-axis direction. Straightforward, it's the x plus 2. Reading this one, if we're doing the dash method, again, we need to read in order of operation. So technically, this is what the y plus 5 is first, then all of that divided by 4. So we also translate 5 units in the positive y-axis, and then we also then finally dilate, and because we're dividing by 4 in this and we're using the dash method, we can read that as dilate by a factor of 1/4 from the since we're changing our y-coordinate, we're technically dilating away from the x-axis. Now, that was the dash method. The inspection method, the first step is still the same. You would still rewrite this, and then you just look at what are the replacements I need to make. Well, clearly in this one over here, the first one I want to replace y with y minus 5, because I'd get y minus 5 plus 5, and they cancel. And I'm left with just e to the x plus 2. Then I want to replace the y divided by 4 with, I want to replace it with y times 4, or the same as y divided by 1 on 4. That's that whole, this 1/4. So that 1/4 fractional sort of stuff gets really hard in inspection. It's really easy to make mistakes. And then also over here, I want to replace x with x minus 2, and we'd get x minus 2, then the plus 2, and they cancel, and we're working towards that form. And same over here. We just think of what are the replacements I need to do to this on the this left one, to end up getting it to look like this. And you should be able to, if you're proficient in that. That's it for that exercise, and I look forward to seeing you back at school. If you have any questions, put them in the comments section below, or in Google Classroom, or you can still email me. That's it. Have a good evening.